So let's carry on with the official 127 stuff. Let me close that and go to here. All right, so we are now down to Windows. We've been doing Linux so far, and we're about halfway through the course. We're actually less than halfway, which is fine because there's a lot of other topics coming up. But now we're going to do the first Windows thing, and this is the most important project in the class. There are two, I think I mentioned before. The most important projects in this class are ED202, where you learn to do a basic buffer overflow on Linux, and this one, ED308, where you learn to do a basic overflow on Windows. Those are the two that are the fundamentals of everything you need, and all the rest are minor variations on that. So this is an important one, and in order to do it, you have to understand Windows, which is very different from Linux, and I think it's fair to say it's much more complicated than Linux. Windows is an all-purpose operating system to a much greater extent than Linux. Most Linux, you don't actually install very much of the options for Linux. You install a basic system, and you only install additional software to do many use cases. Windows seems to have everything built into it right from the start. Anyway, so all right, so let's talk about Windows. So here's the topic. We're going to talk about the Win32 API, the Application Programming Interface, DILs and PE files. DILs are dynamic link libraries, and PE are portable executable files, which are all Windows executables. Then the heap, how threading works, the DCOM, Component Object Manager, distributed, something like that. We'll talk to it, which is a strange system of Microsoft of making software reusable, exceptions, and debuggers. So the first bit is general fundamentals of how Windows software works, and we go to this in much greater detail in the malware analysis class 126. Okay, so in Linux, you can do int 80 to talk directly to the kernel. Remember we talked about this, you load a kernel call number in EAX, you call int 80, and off you go executing a kernel routine. In Windows, you come through the Windows API to do the same thing. And this is a set of libraries you load, and that changes with each Windows version and service pack. So you have to read the documentation for the version of Windows you're using, and then make the calls to the Windows Application Program Interface. So here's an example. If you want to create a window, you just call create window EX, and then it has parameters like the title of the window, and other things here like how big the window is and whether it can be resized and whether it has a scroll bar and things like that. This is how you do anything. You call a Windows API call to do it, and this one will return a handle to that window. So later on when you want to do something like close that window, you can call close with this handle to tell it which window you want to close. So that's what you do, and you just have to read the Microsoft documentation to learn how these things work. So these come in as libraries, which you can load. They're precompiled code, and you load them by including them in your source code for your application, and they're loaded when executable files run. And if you use Process Explorer, which is a Microsoft product, since they bought sysinternals, it gets you details of processes. Here is SVC host running here, a service host, and you can click on it and then look down here and see all the libraries that it's loaded. And you can see it's got the Advanced Application Programming Interface 32 library, and cryptography base, and GDI for graphics, and on it goes. So these are just many libraries loaded by that process. Even the simplest thing like Notepad has many libraries. These are called portable executable files, EXEs and DILs, and for that matter .coms, which are not as common. They are all portable executable files. Anything that runs in a Windows environment is in this format, portable executable, and applies to both 32 and 64-bit files. And the point of this is it contains the header of the portable executable file tells Windows how to launch the program. So it has to know all the libraries to launch and what memory segments to allocate and other things about how to start the program. And the tool that works for this is PEView, which shows you the structure of a file. So this is Notepad, and it has the main sections here, text, data, resource, and relocation, about which we'll say quite a bit more later, but I should mention, might as well, while I'm here, say it. The way to remember the names of Windows objects is that everything is named the opposite of what it is. That usually helps to remember everything. So the text section does not contain any readable text. The text section is the machine language instructions, which just looks like random bytes. Readable text would be in the resource section, or maybe the data section. And the relocation section is used to relocate something in memory to a different location, called rebasing, where something wants to load at one address, but when it tries to load there, something else is already there. Or you might have address space layout randomization turned on, and then it chooses a random location every time it loads something into memory, and it uses the relocation section to adjust the hard-coded addresses that might need to be adjusted when it moves to a different location than the expected location in memory. And, as I mentioned before, one important thing you have in the headers is the import table. And the import table tells you all the libraries it needs. So here you see it needs advanced API 32.dil, kernel 32, GDI 32.dil, user 32.dil, and so on. This is the part of the header, the import table, that tells it all the libraries and functions it needs to bring in. All right, so that's what you just have. Every text is instructions to execute, and relocation is used to relocate things, and the rest of these are variables and constants that are used by the program. So DILs have a base address where they would like to load, but they might not be able to load at their base address, and then one of them has to be moved. They call that rebasing, where it tries to load at this address, and it can't. It has to move to another address, so that uses the relocation section. All right, so let's try Kahoot about that stuff. I should have some Kahoots loaded up in one of these tabs. Here we are, 6A. All right. By the way, those of you that wrote complaint letters to the administration, I want to thank you. We had a meeting with the chancellor today, and he seemed very impressed by our program, and I think he's going to restore some of our funding for next semester. It's not a sure thing yet, but it looks good. So, and I think the student complaint letters were part of what impressed him. So, it's good. Otherwise, our program would be greatly diminished. All right, I guess that's it. All right, so what kind of file contains precompiled library code? All right, those are libraries, dynamic link libraries. All right. All right, how about the functions Microsoft provides to access the kernel? That's the Application Programming Interface, the API. Syscall is what they call it in Linux, but in Windows it's the API. All right, what's the format for all Windows executables? Portable executable files, which includes EXEs and DILs and others. Portable executable is the general format of them all. All right, what section is used for rebasing? The relocation section contains the commands with hard-coded addresses and information about how to fix those hard-coded addresses. All right, what section contains machine code instructions? text section. The one with the name that sounds least like it is the one that contains the machine language instructions. And where are the icons? Yeah, they're in the resource section. There's actually a tool you can download, a hacking tool called Resource Hacker you can use to change the icons and text as sort of a joke in games and programs. Anyway, all right. So SO, that's probably not enough for my grader to know who you are. If you want points, you'll have to give me more information. Probably same thing for flowers. But Ruhani, I know who that is. Ruhani's going to get her points. All right. And the other people probably won't get their points unless they give me more information. All right, so imports are programs, functions that you need to use from other code because you're bringing them in from libraries. Now, executables and DILs can both import. Many libraries depend on other libraries. Exports are different between the two, though. Typically, EXEs only export one pointer, which is the main pointer to start the program. You're only supposed to start them in one place, whereas a library will export dozens or hundreds of pointers to all the different functions it offers. So DILs have many exports. EXEs typically have only one. So here's Notepad's imports, and here's the import address table, and you see it's going to load from advanced API, it's going to load all these things like open process token and get token information, and then from COM-CTL32, it's going to load this thing about a status window and so on. This is in the header. It knows all the libraries it needs, and it knows all the particular functions it's going to use in that library. Here's advanced API 32 exports. This is a library, and it has a lot of exports. See, these are the A functions, and this whole screen doesn't even get you to the end of the A's, and you can see from the scroll bar, this is not even 10% of the list. This library has many, many functions that do various things. And you have to read the Microsoft documentation to learn what they all do and the right format to send the data in. Now, so when you load an executable, Windows has to hunt for all those libraries and find out if they're already in memory, it connects to them, and if they're not in memory, it looks on the disk to load them, and if it can't find them, then it pops up boxes like this. Can't find this something.dil. This used to be a huge problem. In Windows 98, this would happen all the time. I still see it occasionally in modern versions of Windows, although it's not as bad as it used to be. And the point is, it hunts for the DIL, looking first in the current working directory and then elsewhere. This means you can include a DIL version other than the one in System32 in case you wrote your application using some function that changed and you want to make sure the right version is there for your function. And this can lead to DIL hell where it's hard to find a DIL, and it can also be used to exploit the machine. And this is what the Americans and Israelis used to destroy the Iranian isotope separators a decade or so ago with the Stuxnet attack. This thing was designed to go on a thumb drive, and when you'd plug in the thumb drive, you would see a file here, and there was a library here, and just to draw the icon here, it would load a library, and the library was right there, and the malware was in the DIL. So the thing about this was you didn't even have to run a program. Just opening the folder to see the file was enough for it to take over your box, which is pretty awesome because it loaded the local DIL, and that DIL contained malware in it. Now, Windows executables all think they are running at this location, 400,000, although, by the way, this is hexadecimal, so that's not really 400,000 in base 10, but anyway, it looks like 400,000. That's the natural location where Windows programs like to run exe files, and so they all believe they're running there. It's a virtual address, and the computer keeps track of where they really are, but the internal operation of the program, they think they're at 400,000. And that's called the relative virtual address. So if you have one process that is really at 300,000 and one that's really at 500,000, they both are mapped to 400,000. So inside, they think they're at 400,000. All right, just like a virtual machine, in a much simpler way, this is just a virtual address. And here's Ollie Debug. You can load your running code in a debugger, and then you'll see the address. Here's some instructions, like push and load effective address and so on. And as you can see, they all are around 400,000, which is a common place most EXEs will load at that kind of location. Unless you have address space layout randomization turned on, in which case they'll keep jumping to random locations. Now, we talked in Linux about exploiting the stack and exploiting the heap. In Windows, the heap is much more complicated than in Linux. Linux typically just has one heap for every application. Microsoft has many heaps. You can split the heap up into many chunks for different purposes, and then each DIL that loads can set up its own heap. So heap corruption attacks are more complicated and confusing on Windows. They still work in the same general way, but there's a bunch of little extra effort you have to put into writing the exploit to deal with the complexity of Windows heaps. So much so that I have not included heap overflow attacks in this course because I couldn't find one that was simple enough. They all had too much irritating detail. And then there's threading. Each process is divided into threads, and processor time is allocated to threads. So you launch a process, and it always has to have at least one thread, and it often has many threads, and then it strobes through the threads. It gives this thread some cycles, then this thread, then this thread, then this thread. And the reason this happens is if part of the program is slow, waiting for something, then the other parts of the program can often move forward, the other threads. That's why it's done this way, so that hopefully your processor doesn't waste time waiting for a slow thing. It does whatever it can be doing, while waiting for slow things like user input and network traffic and hard drive data. All right, so you can see the number of threads in Task Manager. You can see here's the CPU running, here's the number of processes, 41 processes, running 677 threads with 18,000 handles. This gives you general information about how your machine is running. So the processes are applications, either background applications launched by the system or ones you've launched from the Start button. And then threads are parts of those processes. So you can see it's something like 15 threads per process on the average. And handles are just pointers used by the process. You remember back here when we had this example of an API call that opened a window, right here, this is a handle. This is a handle to that window. So every thread will have many handles, just objects that point to information it's using in memory. And so that's why you'll see there's many, many handles here. Every thread will have many handles, and every process will have at least one thread, and usually many. So that's the what's going on here. All right. And you can view all sorts of details about them all in Process Explorer, but I've never had to use this really. This is something I think you'd only need to use to debug something you were writing, software that had some kind of subtle flaw. But in principle, you can see everything down to the thread and the handle in Process Explorer to find out exactly what every process is doing, and that will be useful to analyze complicated malware problems or to debug complicated software development problems. So let's take a look at another Kahoot. 6B, there we go. Maybe we got everybody. Oh, okay, well anyway, one more got in. Good. All right, so what part of the DIL lists the entry points it provides? Those are exports. Exports are the functions the DIL offers for people to buy, like products in the store. You can come in here and have this function, or come in here and have that function. Those are called exports. All right, which memory is a single block in Linux, but many pieces in Windows? The heap. Heap is really complicated. It has some weird structures called like a look-aside list and such to try to lower heap fragmentation. Windows heap is a pretty complicated object. All right, which one of these will have the largest number of instances when running Windows? Threads, or handles, pardon me, handles, of course. Each process has many threads, and each thread has many handles. And only a few processes have windows, so handles are by far the most numerous thing. All right, and what's the allocation unit for CPU time? What object gets allocated some cycles? All right, now that's threads. Yeah, threads get the units of cycles. All right. All right, that's another name of someone. I don't think they want their points. There's someone that can get points. Sid. Andrew Hunter. Good. All right. All right. All right, let's go back to the slides then. All right, so now we can talk about this stuff, DCOM and DCE RPC. This was a little hard for me to understand. These are more ways to write software and run it on Windows, and they both amount to being a lot like libraries. There are some differences, though. We'll talk about this. And this is a lot of why Windows has so many security problems. The point of Microsoft is to make money. They're very clear about this. Bill Gates was clear from the very beginning. Do we send you an email with the real names? You can do that. You can also put a note in Canvas, or you can send me an instant message here. It'll pop up. That would be fine. All right. So Microsoft, the whole point of this is to make it easy for people to sell software and make money on the Windows platform. So you can actually build an application without writing it yourself. You can buy modules from other people called COM modules, and then you can just write a calling routine that calls them with Visual Basic or some simple high-level language. That's the idea. So you can write a COM object in any language you want, and then you can interoperate with code written in other languages, which sounds insane, and it is pretty insane and dangerous, but it is the most productive way to help people sell their code and reuse their code. So you're going to need, if you want to use a COM object written in C++ and connected to a program that's otherwise written in Visual Basic, you're going to have to convert the variables from one type to another, and that's what an interface description language file does. Here's what it looks like. It defines the types of variable that are sent in here. So you can connect two objects of dissimilar type together. That's the interface descriptor language file. And it defines an interface by UUID, also called a GUID. This is a globally unique identifier, and inconsistent with the general rule I've told you that everything in Microsoft is named the opposite of what it is, it's not globally unique. There's a globally unique identifier for the control panel. It's the same on every machine, and so on. Anyway, it's 128 bits long, 32 hex characters. It's a unique identifier. It just looks like long random letters to an object. So you can load a COM into process space as a DIL, and then it's just like a library, like we've talked about. But you can also launch it as a service, and then it will run in the background and offer this service to any program that wants to call it. Running as a service is more stable and more secure, but much slower, 1,000 times slower. So the Service Control Manager you can run on your Windows machine. You see it in Task Manager. Here's services.exe. That's the Services Control Manager. When it's running, you can launch it from the Start button as services, and then it'll show you the running services in the background. Now, there's also DCOM files. And these things, you can make a small parameter change in your program to tell it to use a different location for this library, this COM file, or even from a different machine. You can call a COM interface from the network, which is 10 times slower than calling it on the same machine. So the point of this is you were able to take a library you wrote for one program for one purpose, and then you can decide to share it among all the processes on that machine by loading it as a service, and then you can decide to share it over the network to all the things on your network. And this makes it easy to reuse your code in a larger and larger context. But the consequence is a lot of code that was written for a very limited context ends up being used to make it wildly insecure. For example, Telnet. Telnet was a protocol invented to move a terminal to a computer across a twisted wire connecting them together when there was no internet. So you just type characters one by one and they would be sent over the wire in a simple way to get to the server. And there was no internet, there was no shared connection, so it was not a security problem. But then it was ported to local area networks, and then it was ported to the internet, to where now you're sending sensitive data like passwords over the internet without encryption, because you've lifted it up. And it's not exactly necessarily done with the DCOM, but it's the same consequence. So that's the point. The way this works is you use the RPC endpoint mapper, remote procedure call. It's listening on TCP port 135 of Windows machines, and you send a request to the RPC mapper, and it then tells you all the services that are offered. So it'll send you a map request, and it will then show you floor 1 contains this service, and floor 2 contains that service, and they each have a UUID, and so on. So this one listening TCP port is offering many functions. And many of those functions were originally written to run as like libraries in one process that were not designed to be shared in this way. So this process of Microsoft remote procedure calls has been a huge source of insecure code, and many of these worms and viruses and attacks have gone by finding vulnerable services in this list of services because of this idea. And RPC is used by almost everything. If you open almost any service, you'll find they're almost all using RPC. So you can't stop using it or block it. Everything Windows uses depends on it. It's very multi-function, but some of those functions have typically had security flaws. It's been a big problem. Of course, Microsoft patches them, so I'm sure it's better than it used to be. Anyway, that's the point here. Your code may be designed to run in a trusted environment, but then it gets moved into an untrusted environment. By the way, there's another similar problem. Many people are taking their data centers and putting them in the cloud. And they do things like just take an image of all the machines in their own data center, and then they put them on Amazon machines without understanding that they have not reproduced the segmentation or the firewall. So the Amazon machines are all directly connected to the internet, and their private machines used to be protected by the network or the layout of the network. So there's a whole process of secure cloud migration that a lot of people don't understand or go through. So they end up taking their software and reproducing it in the cloud in an insecure way. The most obvious one being open Amazon buckets. You have a whole database of stuff, and you put it on the cloud, and you don't realize everybody can just see it. So there are tools just to look for flaws in the RPC. Recon, Fuzz, and Exploit are various. You can do this with Spike. Spike is one of the tools that can do this to look for flaws in remote procedure calls. Now, another consideration is how you keep track of the privileges of a process. There is a token available here. There are tokens available with an address, and these tokens are 32-bit integers that define who is running a process. So some processes are running as system, the high privilege. This one's just running as SAM. This one is running as some others. So each process has an owner and has certain privileges that owner might have. And so if you get local administrator rights on the system, you can copy the token and move it to another process. So you can change your privileges to any running privilege. And it is fairly common that people in domain environments have a process running as the domain administrator or something. This does tend to happen because they're running something like a surveying tool or something, and those high privilege processes can then be used to steal high privilege tokens. It's one of the attacks you'll see in Metasploit, steal the token from another process. All right. And then there's exceptions. If you have something wrong in your program, like it tries to divide by 0, or it attempts to execute non-executable memory, or it attempts to execute code or access code in a memory location that is not allocated for the use of that process, then you have an illegal instruction, and that raises an exception, which is a flag for the processor saying stop processing and go do something else. It then tries to handle the exception. If the developer of the program can write an exception handler, If a bad thing happens, here's my code how to handle it. And it will receive a code and try to figure out what the exception is and deal with it. But if the handler is not there, or if the handler does not handle this type of exception, then it passes to the operating system, and the operating system will handle it. If it is in user land, then it will typically pop up an error message saying, this program has crashed, click here to restart it or something. If it's in the kernel, then the whole machine is dead, it has to stop completely, and you get the blue screen of death. It can't continue, which is why everything you launch is in user land, and only Microsoft and device driver makers get to put things in the kernel because it's too dangerous. That's why this way, if your program crashes, it doesn't kill every program on the box, just that one. So you can specify custom exception handlers, and those you can see them in a debugger, which we'll play with a little bit later. You can see the structured exception handler is just a series of addresses. There's code here that will check if it's a certain exception, handle it. If it's another exception, handle it. And if that doesn't work, then pass off to the operating system and let it handle it. All right, so certain kinds, sometimes when you have an overflow or some other memory corruption flaw, you can corrupt the structured exception handler. And then you can change the address of exception handlers, and then you just have to create an exception, and it will run the code you specified. All right, and we'll do that in the project. So we're going to use debuggers. There's some old, Soft Ice was a great one, but it's out of date. We can't use it anymore. WinDebug is the most powerful one by far, but it's also the most difficult one to use. And it's gotten a little bit better with Microsoft's latest updates, and we'll use this quite a bit in later projects, but it's very hard and frustrating to use. But it's very powerful. It can debug the kernel, and it's very easy to write scripts to automate debugging in WinDebug. But what most people prefer to use is OllyDebug. This is a very famous, very popular debugger. People use it to cheat on Windows games and such. But the problem is it only did 32-bit code, and it hasn't been updated in many years. There was an attempt to move to OllyDebug 2, but that didn't help it very much. And OllyDebug sold their source code to Immunity, which made a living debugger based on the source code. So the modern best debugger is probably Immunity. And that's what we're going to use in the project tonight. So Immunity is a very good one to use on Windows. And so when you open Immunity Debugger and load a program, you have four basic areas. You have the assembly code, the running instructions here. You have the registers over here like EAX and EBX and ESP. You have the stack down here. You see, and you have a place down here for hex dump where you can just dump any region of memory and see what it looks like in hex and in ASCII. And in the bottom right corner is the most important thing probably. This is the status. It tells you whether the program is running or paused, which is the first frustrating thing. You have to learn to look here frequently. And the other thing is the instruction if something has crashed or you have an error message, you'll see it down here, and that's often very helpful too. And I'm going to demonstrate all this tonight as we do the most important Windows project where you debug a simple buffer overflow with Immunity Debugger. So here's the last Kahoot. 6C is good. All right. Give it a few minutes. We made it up to a few seconds. I made it up to 10 last time. Pretty good faces. Good. There's Plant Daddy. All right. All right, so where do you find the inputs and outputs of an object? in the interface description language. All right. Which one is 128 bits? The universally unique identifier. All right. Which structure is used when you divide by 0? That's an exception, so you go to the exception handle, the structured exception handler. All right, which one is listening on port 135? The remote procedure call is listening for requests from other machines on your network and providing many services. All right, which one of these is 32 bits? The privilege token that determines who is running a process. And which debugger can debug the kernel? WinDebug, the one from Microsoft, the one the real pros use. Hard to use, but very powerful. All right. All right, that's another person I don't think would care about their points. But Sid, good. Sid and Rouhani, those are real names. I know who good points too in that case. Good. All right, good.